Hi, my name is Vera Mays. I'm with the TSC Learning Commons. I'm one of the math specialists here. And today I'm going to be working through a brief review for Test R. This is designed to help you be prepared and see what areas you might need a little bit more help in. And it is not designed to be all encompassing, but to just give you, like I said, a brief overview of the main topics, and you can see where you might need some more help. All right, so the first question we have is simplifying an expression, this whole section. So what we're looking at is we need to get rid of these parentheses, these grouping symbols. So we're going to go ahead and distribute in both cases, watching our signs. So 3x minus 12, being careful to distribute the -2, right? And then we're going to combine like terms. So I see an x term and an x term. So I like to rewrite them close to each other, but you don't have to if you can see it. And then I see a -12 and a -12. So I'm going to combine these guys. 3x minus 2x is 1x. You don't have to write the 1. I'm just wanting you to see where everything went. So -12 minus 12. So they're both negative. So we add them and keep the sign. So this would be the first example simplified. The second one is simplifying fractions. So sometimes it's harder to see like this. It's easier to see maybe if you rewrote it as a divide. And then there's this saying where you keep, change, flip. And you're doing division with two fractions. So you keep the top, change the division to a multiply, and then flip the bottom. And so what we're doing is a shortcut on using the reciprocals, since multiplying is the inverse of division. So then we can go ahead and multiply straight across, or you could go ahead and do some canceling if you want. Let's see, we have 18 over 12. Now you could go ahead and put this in your calculator. Most of the calculators that we're using at this level will reduce this for you. But if not, you could say, okay, well, they both divide by 6. Let's see what that does for us. So that gives us a 3 halves. And these are always going to say simplify in the directions. So they do want you to not stay with that 18 over 12. They want you to simplify this as much as you can. The next question is again about parentheses. So we're going to go ahead and distribute in both cases. And again, you notice we've got some negatives and some positives. So we've got a 10y minus 15. Distribute the -4. And again, I'm going to regroup with like terms. So 10y minus 12y. It does help my brain if they're close to each other. And then let's bring down that -15 and that +2. So 10y minus 12, they're like terms. So 10 minus 12 gives me a -2. -15 plus 2 gives me a -13. So my final answer would be that. All right, so now as we're simplifying expressions, one of the things we have to be able to do is multiply two binomials together. Now, I think most of us have learned previously a cute little saying. So FOIL, which kind of guides us through the process. It's really just a distributing process, but this helps us remember all the little pieces. So we're going to take the first times the first plus the first times the outer. Now we're going to do the I, that's the inner times the inner. And then the L is the last times the last. And then we're going to go ahead and simplify each term, see if there's anything we can combine, and we'll be done. So x times x, remember when you're multiplying, you have the bases are the same. You add those exponents. Positive times negative. X times 5 gives us a 5x. We usually write the number before the letter. Positive times positive. See that? Positive times negative again. And I see that I have two like terms here. So I'm going to bring down the ones that are not similar to anybody else. These two are the only ones that have exponents that match. So -5 plus 3 is a -2. And there's our final simplification for multiplying, because you'd see it says to multiply. So we could have stopped, but it does say simplify. So it wants us to do any cleanup, any combining of like terms that's possible. All right, now we're going to focus on the section with exponents. Mostly this would have been the first week of school where you learned those basic exponent rules. And again, to help my brain, I kind of like to rewrite this. We are multiplying this group times this group. So let's put our numbers together, our x's together, and our y's together. And I'm going to go ahead and put that little 1 to help me remember that rule. So negative times positive again. And then the x's, we keep the base, add the exponents. With the y's, we keep the base and add the exponents. That's why I went ahead and put that little 1 up there. So when we went to add the exponents, it reminded my brain that it was there. All right, simplifying exponents. We learned that one of the rules was we're not allowed to leave negative exponents, and we're using the reciprocal idea that if they're on top, the reciprocal would push them to the bottom, or if they're on bottom, the reciprocal would push them to the top. So the first thing I want to do before I combine any like terms is go ahead and make sure everybody's on the level that they need to be. So this x to the -3 is really a 1 over x to the third, which means it pops it to the bottom. So I took care of that guy. This guy's positive, so he can stay up here. This guy is negative, so he does not want to stay on the bottom. Again, remember, we're using that reciprocal, and that would pop it to the top. That's that guy. And then y to the -4th, which would mean that one would pop to the top. So now I can look at this and group it by similar type of letters. So I see an x to the first on top and an x cubed, and I see a y squared and a y to the 4th on top. All right, division means we keep the base and subtract the exponents. The larger exponent is on bottom. So the x's, when they cancel, this is like having 1x over 3 of them. And so one of them cancels, but it leaves 2 on the bottom. And all of the y's are on top. So we're multiplying. So we keep the base and add those exponents. So there's our final simplified answer. Writing a radical, our writing between radicals and exponents, there's a process. So if you keep in mind, a radical is normally, it's got an index here, and I'm just going to put an x here and another exponent potentially on the inside. Now, when you go back and forth, the thing that helps me the most is thinking about, so right, I've got z raised to the 3/2. So I'm wanting to write this as a radical. So this is my a, and this is my b, to be able to compare to the radical expression. And the way to keep this in mind is remember that the roots on a tree are on the bottom, right? So your root or your index is always going to be the bottom number. So rewriting this, here's my z. The root index is a 2, and the exponent on the inside is a 3. So remember, the bottom number, that root index number, is always on the bottom. All right, here's another one where we want to practice with writing without negative exponents, but it has a grouping symbol. And so what I'm going to do is, again, separate the, oops, that's a little bit big for a exponent. So this is a to the -2, but it's to the -1 power. And then I have a b to the third, the -1 power. So remember, when we have grouping symbols, we multiply. So negative times negative makes that a positive. Positive times negative makes that a negative. Now, we're not allowed to leave any negative exponents. I've simplified the parenthesis, but I'm not done because we got to go back and do that reciprocal idea or moving a negative exponent to the other layer. So when we move it to the bottom, it becomes a positive exponent. So we are really rewriting this as its reciprocal. And then when we multiply straight across, the a squared is on top and the b cubed is on bottom. All right. One of the other things that we reviewed in this first unit was simplifying radicals. So if you remember, some of these come out nice and pretty. So I would always try them on my calculator, put in the square root of 49, and this one pops out lovely. So square root of 49 is just a 7. There are 6 of the x's. So I'm going to write this out real quickly, and then I'm going to talk to you about shortcut. 6 of those, 2 of the y's. Remember, this is a square root, so I'm going to go ahead and write that index in there. Since we're kind of lazy, we don't always write it if it's not. If it's 2, we don't write it. Anything else, we do. So this says I need a pair of something to be strong enough to come to the front. Well, here's a pair of x's. So they're going to send a representative to the front. Here's another pair of x's. Here's another pair of x's. And there's no x's left over, so cool. All right, and then with the y's, here's 2 of them. So they're going to send a representative to the front. And you can see there's nothing left over inside the radical, so it disappears. We've put all the pairs to the front, and now we can simplify this. So 1, 2, 3 of the x's and 1 of the y's. If there had been leftovers, they would have stayed inside that radical as like a protection. All right. One of the other things we learned to do with radicals and rationals is that we have a rule that we are not allowed to leave a radical on bottom. And so we have this process that completes it, and it's called rationalizing. So we know if we multiply by the same thing, that's going to give us a square root of 25, which comes out as a nice even number. But we also know if we do something to the bottom, we have to keep it balanced and do it to the top. So here we're multiplying 3 by the square root of 5. Square root of 5 by itself cannot simplify. So I'm going to look at that and just bring it over. So you're looking at the bottom. You're trying to get the denominator as a whole number with no radicals in it. So you're going to multiply by what would complete it and make it a perfect square so you can simplify it. Now, if the 3 and the 5 had been numbers that would simplify with each other, we could have continued and reduced before we got our final answer. All right, the next unit that we did some review and work on this topic, this module, was factoring. So when you do factoring, one of the first things you always look for is a GCF. We're going to look to see if there's any common terms. So when I look at 2x cubed and 8x, I look first at my numbers. Well, 2 goes into both of those, so I can factor a 2 out, and they both have at least 1x. All right, so if I factor the 2 divided by 2, leaves me with a 1. X cubed, losing one of its x's, gives me an x squared. 8 divided by 2 leaves me with a 4. And the x only had 1x, and it went to the front. All right, so now we say, can we continue to factor this? And what I see is, so let me write a couple of things here. With GCF, we're going to look, there's 4 terms, and we're going to use that on the next one, so we can use grouping. We do look to see if there's a difference or sum of 2 squares. So this one is a difference of 2 squares. And we've learned to factor that. X squared becomes x times x. That's the way to get it back if we were doing that FOIL. Factors of 4 that are the same because we do not have a middle term would be 2 and 2. And this is that special one where one's always positive and one's negative. So now I can't factor this any further. I can't factor this any further because it's just the first or this one. Okay, so this second example on this screen is a factoring by grouping. Anytime I have four terms, that's going to be the one that I start by looking for. I look at the first two terms and then second two terms, groups of two terms. I look at these guys and see if they have a GCF. So when I look at x cubed plus 3x squared, I see that they both have at least two of the x's. So I'm going to pull that to the front. When there were three and we took out two, that left one. Plus, we took out the two x's, so it leaves me with a 3. Bring the next sign straight down, and then look at the 2x plus 6 and ask yourself, what do they have in common? They don't both have an x, so I can't pull an x out, but they both have a 2. So if I divide both of these by 2, 2x divided by 2 leaves me with an x. 6 divided by 2 leaves me with a 3. Now, if we have done our work right, you will always see a matching group here. So now I can factor this one to the front, and it leaves behind an x squared plus 2. And then the common term, you can put this in front, you can put this as the second one, it doesn't matter. Now, because this is the first degree, I can't factor this any further. I pulled out its common terms, but this one is a second degree. So I asked myself, oh, wait, this has got a plus. So it doesn't have the same special property as this difference of two squares. So until we learn and work with the quadratic formula, this one will not factor any further. All right, so this one, always start, is there a GCF? 9 has 3 and 9. 3 will go into here, but 3 doesn't go into here. This has a y, this has a y, and this one doesn't have a y, so it looks like no common terms. And because it's not four terms, I'm not using grouping. The middle term didn't disappear, so I can't use sum or difference of two squares. So this one, I look to see, is it a special pattern? Because some of us have learned if this is something squared and this is something squared, and the middle is double, then, so multiply this times this, you get 12y squared, and this is a 2 times the 3y and the 4. Then we see it's one of our special patterns. So I'm going to go ahead and put the minus and the plus, and so then I can go ahead and rewrite this. This has to be our first component. This one definitely fit the pattern of a square, and then a double of their product. Because it's a positive 16, but it's a negative in the middle, the only way to get that last times last is positive, means I'm putting negatives in here, and then the 4. And a good way to check yourself is to go ahead and FOIL it back out, just to make sure that it really does match with your original question. Now, if you didn't learn this particular special factoring term, you could also use the AC method, or you could use trial and error. This one. All right. I just wanted to mention this difference of two squares one more time, just because it pops up a lot. So remember, two terms with a minus is that difference of two squares. So x squared would be x, 16 would be 4. And remember, this is always one positive, one negative, and the order that you do that does not matter. So now once you rewrite it as something squared minus something squared, you know exactly what goes into each of the slots. FOIL it out, and those middle terms should disappear because one of them is a positive 4x, one is a negative 4x. All right, so this one, always check for the GCF. This one has a 2. Nope, no 2. Okay, so can't do a GCF. doesn't have four terms, so I'm not going to use grouping to start with. It's not a difference of two squares. And so this one, we're either going to use the AC method or trial and error. So I'm going to try the AC method because we haven't done one of those. So remember, every quadratic, because this is a square, is of the form ax squared minus bx plus c. All right, so here is my a term. Here is my b, the 1, and the c is right here. So the AC method, right over here, says take the a, which was 2, times the c, and negative 12. All right, this is how I'm going to figure out which pieces will combine to give me the b. They have to multiply to give you the a times the c. They have to add up to give you the b. So we're going to make a quick little chart. Factors of 12, 1 and 12, 2 and 6, 3 and 4. Now it needs to be a negative 12. So one of these needs to be positive, one needs to be negative. So what I'm going to do is go back and change it so I have those pieces. So positive, let's let the 1 be negative, and then we'll let the 12 be negative the next time because we don't know. And then we've got negative 2 and 6, or a positive 2 and a negative 6. Negative 3 and 4 are 3 and a negative 4. All right, so these are all the combinations that multiply to negative 12. Now, what we're going to do is we need to get that b, that negative 1, when we add them together. These guys give me an 11. Nope. These guys add to negative 11. Nope. Negative 2 plus 6 is a positive 4. That is not the negative 1 that I'm looking for. 2 plus negative 6 is a negative 4. Nope. Negative 3 plus 4 is negative 1. Okay. That's exactly what I was looking for. So the process is leave the first one alone. Leave the last one alone. And what we're doing, we're taking that negative 1x that was in the middle, and all we're doing is rewriting it. We're kind of pulling it apart. So we could say that that is a negative 3x plus 4x. This gives me the coefficients that I need to make this grouping method work now. So the AC method looks at the coefficients, but it's using the grouping method then to break it apart for us. So just as a reminder, we're 2 at a time. We're looking for the GCFs of each group. So this one, 2 and 3, no, so no numbers. X squared and x, so 1x could come out of both of those. And that leaves me with 2x minus 3. Bring the next sign down. What do these guys have in common? 4 divided by 2 is a 2. Negative 6 divided by 2 is a negative 3. And now we can see there is a new GCF. So we can pull out the 2x minus 3. And what's left? From this one, we have an x left. From this one, we have a plus 2. And if we were to go back and FOIL this back together, it'd be a great way to check and make sure we really do get that product. All right, so find all excluded values. So the one thing we need to remember, until we get to calculus, we have to be really picky about remembering that we cannot divide by 0. So what we're doing is we're really finding our domain because we're finding the values. What can we use for x? So in this case, we're looking at the bottom and we're going to set it equal to 0 so that we know which of our x values we are not allowed to use. Now, because we're solving, we could use the square root property. We could factor this, but it takes longer. So let's go ahead and get that x squared term by itself. Let's bring that 9 over. And then we can take the square root of both sides. But remember, when we artificially introduced the square root, we don't know if it was a positive number that got squared or a negative number that got squared. So we're going to add that. Square root of x squared. If you go back and rewrite that in the a over b form, you can see that gives us x to the first. Plus or minus, square root of 9 comes out beautifully. So this is saying that I cannot use +3 and -3. They will give me a 0 on bottom. So those are the ones that I want to avoid. If I'm asked to rewrite this as a domain, think about it on a number line. Can't use -3, can't use +3, but I could use everybody else in between. So its true domain goes from a -infinity to a -3, jump over that -3, continue until you get to +3, stop and jump over it, and then continue until you get to positive infinity. These are the two numbers that break our number line up that we are not allowed to use because they will set our bottom equal to 0. All right, simplifying. So we're going back to trying to break each level apart. So what we're going to do is we're going to factor the top, factor the bottom, and then like most fractions, see if anything reduces. So when I look at this one, I say, okay, what do they have in common? Well, 4 goes into 4 and 28, so I can pull a 4 out. They both have at least one W. 4 divided by 4 is just a 1. I had 2 W's, I took 1, so there's 1 left, minus 28 divided by 4 is 7. And if you need to do this, go off to the side and ask yourself how you could reduce it. What do you get? Sometimes it's nice to see that visual. Okay, so here's our top. All right, let's do the bottom. Again, we're looking to see what do they have in common. So they both have a 7. They both have at least one W. So 7W squared, if I take 7 divided by 7, I get 1. I pull one of the W's out, I'm left with 1 W, minus 49 divided by 7 is a 7. I only had 1 W, and I pulled it to the front. So here's our bottom. It is nice to kind of keep your true work clean. So I like to go off to the side and do some of my scratch there. And that way your teacher can follow your process if they do any partial credit or not, or you can follow your own process a lot easier. I do see that this cancels with this. Yay. I have a W and a W that cancels. So this one came out pretty clean, just one nice little fraction. But do each layer separately. And that way you're not so overwhelmed with the work, and then put it back together. At least that's my suggestion. Okay, so that's the highlights of what's in this test for Test Review R. So I hope that you have benefited from watching this, and that if you have any other questions, come see us. You can use this QR code to get logged in for tutoring, either on Zoom or face-to-face. So good luck on your test.